So what are we going to talk about today? I want to talk a little bit about how game theory and the application of game theory can help break down silos in your organization. And then I also want to talk a little bit about the characteristics of high-performance organizations. And one of the things that we've recognized in those organizations is complexity. And out of this DevOps movement has come a movement towards SRE and site reliability engineering. And I'm going to talk about how that relates back to DevOps. And ultimately, like, what do SREs live and breathe, which is OLI and SLI and O's. And I just think that's funny, so I wrote LOL. So let's talk about some game theory. Anybody in here mathematician, like dig on some math, like are super good fans? All right, so I'm going to be completely wrong about everything. Forgive me. All right, so I'm terrible at math, but luckily we're not going to be really talking about math. We're going to be talking about theories in games. So what is a bad equilibrium? In the sense that, we want to talk about organizational culture. And that is a strategy that all players can converge on, but really doesn't produce a desirable outcome for anybody. So what this kind of looks like, and if any of you are familiar with the DORA State of DevOps report, you've seen this before, but this is kind of like the J-curve of transformation. And what happens is organizations quickly, they figure out, oh, hey, I can automate some stuff, and they task dev and ops to go automate things. And what they quickly figure out, and that's the strategy they're converging on, but they quickly figure out that that strategy only gets them so far, and they hit a ton of technical debt and problems where it requires a lot of collaboration and communication to resolve. And so they get stuck in that pit, and they're not really able to get out. So, what are silos? How does this affect people? I realize it's a cooling tower, not a silo. Somebody told me that the other day, and I felt really bad. But silos can be defined as the kind of like the contention that exists between various functional barriers within an organization. Now, typically that contention will exist between teams where change management and policies are there because risk is so high. And one of the things that I like to talk about in game theory is this idea of prisoner's dilemma. I know you know about that. Who else has heard of the prisoner's dilemma? Got a few hands. So this is a concept of game theory where the optimal outcome of the game, there's no one player who has an incentive to change their strategy even after considering somebody else's strategy. And to help illustrate this, I'm gonna play a game show from Britain called Golden Balls. And this show was on the air about 10 years ago, and it got canceled. And I'll explain why in a little bit why it got canceled. But let's go ahead and figure out what Prisoner's Dilemma looks like in a game show.
I know you're the last two people in the country I have to explain this to, but you have two final golden balls.
That's how I would feel right there. That's me. So, what happened here? Other than obviously Stephen being gullible and completely like revealing what he was going to do, you notice Sarah never actually said, she never said I couldn't live with myself. She just said people would be disgusted with me, and that's okay to her. So, what really happens here is the Nash Equilibrium says that each one of those players, their greatest incentive is to steal. And the game show designers were counting on this because they don't want to pay out money. It's not in their best interest to give away 100,000 pounds or whatever. So, in most cases, both people end up stealing and nobody gets anything. So, to talk about what we're gonna cover next, we need to cover a little bit about Pareto efficiency. How many people have heard of this term before and understand it loosely? Yeah, I know math guy over there does. All right, so Pareto efficiency is a state of allocation of resources in which it is impossible to make any one person better off without making at least one individual worse off. It's a zero sum. So the best way to explain this is, we have 3 people and a piece of pie. Cut the pie in half. 2 people are going to get the pie, but 1 person is left out. Now, there's really, you could say, all right, well, we're going to cut it in thirds, but that's not, that's not saying we're Pareto efficient. That's Pareto neutral. And we'll talk about inefficiency later, but the idea is like there's no way to make that 1 person better off. You could also look at it this way from the movie War Games, where both sides nuke the hell out of each other and game over. So, what is Pareto inefficiency? And this is a situation that's inefficient where if someone can be made off better, then someone can be made off better while even after compensating those who made worse off. And what that means is we have this piece of pie, and we're going to cut it in 4 pieces, and sure, we're going to throw away a piece, but at least 3 people, they each got a piece of pie, even though it wasn't necessarily totally efficient. So when we combine these 2 terms, we have Pareto inefficient Nash equilibrium, and that's the idea that dev and ops, they're at odds, they're butting heads, and they're not able to come to an equilibrium. So what do we need to do? We need to change the game. And we're going to see the same show, different contestants, and we're going to see how Nick over here changes the game. All right, so what actually happened here is we saw the Nash Equilibrium get pushed into split. And how did that happen? Well, Nick told Ibrahim, I'm going to steal. And really, there's nothing that's going to change that. So Ibrahim thought to himself, well, my chances of getting money are higher if I trust what he's saying rather than doing steal and not getting anything. And this effectively broke the game. Like literally they canceled after this season because people came on and started doing this and they would just keep giving away the money, and that just, it made for bad TV. So, the story here is we have a new equilibrium. We changed the game. And what the Pareto Inefficient Nash Equilibrium theories tells us is that we have that permission to go and change that game. So if we take it and we look at it from a developer and an operations perspective, and we give both developers and operations the responsibility for operating this software that we're building, we are effectively changing the game. We're making both of those teams responsible. And one of the ways I've seen organizations be successful at this is putting both dev and ops on call. And that's critical to be successful. So, and ultimately, the lesson that we need to learn here is that silos are extremely easy to defend, but they're also extremely difficult to attack. And if we want to attack them, we have to change the game in our organization. So, one of the other things that we need to talk about in terms of changing the game effectively in our organization is the culture. And how many are familiar with the Westrum culture model? I've heard of this guy. So he is postulated that there's 3 different type of cultures in IT organizations. You have pathological, you have bureaucratic, and you have generative. And generative is all these bullet points that I'm about to go through, and then pathological is the complete opposite, the polar opposite. And then in the middle, you have bureaucratic. So the first point is that information is actively sought and that there is a measure of cooperation in our organizations. The next point is that, can you guys bring the mic down? I'm getting a little bit of feedback. There's no more video, so you don't have to worry about that. The next one is that messengers are not shot. They're rewarded for bringing information forward to the organization that helps them be better. We have a sharing of responsibilities, and that's talking about the Pareto Inefficient Nash Equilibrium, is we share the responsibilities of our organization. That cross-functional collaboration is celebrated and rewarded, and that bridging is always encouraged. The next one is that retrospectives, and I don't like calling them postmortems because, to be honest, nobody died, right? So failure causes inquiry in our organization, and we share that knowledge between each other. And finally, new ideas are welcomed. Novelty is celebrated and rewarded. And again, I think one of the things that we can, as a common theme across all of these, is celebration, is reward, is positive reinforcement, if you want to talk about behavioral therapy. We want to reinforce these behaviors in our organizations. So I want to bring up the percentage of work that's done manually in high-performing organizations, because at this point we've kind of pushed past the DevOps modicum of success, right? Our organizations, we're doing the DevOps. Automation is celebrated. We're deploying hundreds of times a day. But one of the things that's a common theme across these high-performance organizations is that all that manual work has been eliminated. And if we put automation in place, this frees up those engineers who were working on those problems before to do new things. And some of those new things include, well, if we look right here, it says that high and elite performers leverage expertise and learn from their environments to see jumps in productivity. So how do we learn from our environment? And that's where we start focusing on stability issues, and we start focusing on scale. And this is really the rise of the site reliability engineers. And we've heard a lot about observability, but that really is what we champion. So, I mean, I'm sorry Bruce Banner got covered up, but I'm that dude over there. But the whole idea here is that these are our superheroes in our organization. They're there to make sure that our software gets deployed and it's available to our customers at all times. So what are some of the tools and processes that our organizations can leverage to collaborate and communicate? Obviously, a lot of people use Slack, Git, and PagerDuty, but this new buzzword, observability, keeps coming up. I keep hearing this word. And what are some of the tooling that goes around it? And we're going to focus mostly on distributed tracing because some of the other speakers already presented on monitoring and logs. And my expertise is around the distributed tracing part. But before we can talk about that, we need to talk a little bit about observability. And we've had really good definitions so far from some of the other presenters. So I'm not going to go too deep. But one of the things I want to say is that observability is not just tooling. It's more of a movement within an organization similar to the way that DevOps is. And that we're no longer treating our services like Schrodinger's cat, right? It's not a black box. And we have a lot more context around the events that are happening within our applications. So, all right, yeah, fine, it's tooling. If it is tooling, it is monitoring, instrumentation, structured logging, alerting, dashboards. I can think of another 5 things, but if you need to put tooling around this, and you do, those are the things you need to do observability. So why does my organization need this? And I want to get a show of hands. How many of you have staging environments in your organization? Keep your hands up. How many of you trust your staging environments? You can put your hands down if you don't trust them. Yeah, that's like pretty much the same thing I see from everybody, right? Because that's your staging environment, right? It's nice, you got somebody pruning, you got somebody picking stuff out of your hair. It's fantastic. I recommend it. And this is your production environment, right? Just pure insanity and chaos, right? And that's my point, is that we're never going to emulate this in staging. It's just not possible. And so how do we get information out of our production systems? And what observability enables our engineers to do is to get context, status, and expectations out of all of our application communications. And I love that Aaron said the other day that root cause analysis is dumb, essentially. Like, we have contributing factor analysis. We have this idea that in any given failure in these large, complex systems, there's going to be multiple issues that cause the outage. Again, the gravity and airplane analogy kills me. Like, I'm going to have to use that at some point. So in order to observe our systems, we have to emit signals from it. And that's where distributed tracing comes in. And some of the things we're trying to answer with distributed tracing is, for instance, how many times a system is retrying or backing off? Like, what are my request parameters? Or what are the query statements that are happening in my service? And what's the timing around it? And are we falling back to defaults? And other things we care about are top-level exceptions. Or whenever something breaks, we want to know the first exception that happened. And so, again, how do we monitor systems to be more observable? We have to wrap those communication functions within our apps with distributed tracing implementations. And this is just a few of them. You have community libraries such as OpenTracing, OpenCensus, and Zipkin. And then you have vendor libraries such as Instana, SignalFX, Dynatrace, and Datadog. Now, each of these solutions are going to support many of the same technologies, some more or less than others, and they all have some level of effort of implementation. So it's important to look at all your options when you're looking at this tooling and making sure that you're making the right trade-offs, because that's what engineering is. It's a series of trade-offs. So distributed tracing is also known as distributed structured logging. We have larger payloads, and we have a lot of context around our data. And you can learn about the standards here, or I'm actually doing an open space after this where I talk about what distributed tracing is. and how it works. So if you're interested in learning how it works, you should come to my talk. So there was a talk at SRECon done by Uber where they showed a microservice graph. And this is a great illustration of what distributed tracing unlocks, because they wouldn't be able to build that graph without distributed tracing. And it's a chicken and egg scenario here, because they wouldn't be able to run this without distributed tracing. So you need one to have the other. And this is extremely complex, by the way. This is thousands of microservices communicating with each other, and you need observability in those types of systems. So how does observability enable a DevOps culture? And I want to take a look at a production microservice that I manage called Single Music, and we've instrumented it with distributed tracing. So Single Music is a small startup based in Nashville. We help people sell their music through Shopify. It's an integration product. We soft launched in 2018 with 15 microservices, and since then we've grown to over 28 microservices with 0 additional engineering resources. And we've been able to do that because we have good visibility into our system, and we can easily understand it. Because DevOps, Gene Kim says that DevOps allows small teams to achieve great things, and I'm going to submit to you that observability enables those small teams to be effective while doing those things. For example, we have the ability to visualize our environments in a Jurassic Park-esque way, which is awesome because it's Unix, right? And so, but we also have the ability to collect metrics, which in and of itself isn't that impressive. But if we look up here on the top, we're able to correlate those metrics with each individual component all the way down to the host level, so that whenever there's an event, we have context. We have the entire picture. And furthermore, since we're able to transmit signals from every service, we enable powerful insights into production applications so we can debug the system. We can build those dependency maps like Uber did. And where SREs and engineers can track the golden signals on every operational aspect of their system. And if you don't know what golden signals is, come to the open spaces. I'll talk more about it. Because, again, we're able to visualize the traffic in between all of our systems. And we can also visualize patterns in our applications. This here is a function that is actually backing off and retrying to get a log from a Redis database. Can anybody recognize that pattern, what that is? Yeah, it's pretty much an exponential backoff. Yeah. And so like we're able to easily confirm, hey, we implemented exponential backoff. Does it work? Is it doing what it's supposed to? And it's really simple to confirm our hypotheses with these systems in place. Furthermore, we can visualize whenever things start going wrong. For instance, we have a service here that is having a log n rise in latency due to a pattern that we implemented on a database access. So essentially, every time a transaction happened, we would read the transaction, or we would read all of the other records first before inserting a new one. And within 6 hours, our latency went from around 15 milliseconds to over 3 seconds. But not only can we recognize the slow death of a service, but we can recognize when we fixed it so that we can say, all right, problem solved, move on. So when we focus on observability, we enable our organizations to understand the behavior of our system. We empower our engineers to find and fix the problems. It enables us to build more reliable systems and ship software faster. And ultimately, it promotes empathy through the understanding, through the transparency, and through the communication of our systems. You guys can follow me on Twitter, not sure if Kevin, and I will say that you should use game theory to change the game and put all the stakeholders on call, including managers, so that they can feel the pain of an outage. It's the only way you're going to get buy-in for this stuff. And observability complements, and more importantly, I feel that it enables a DevOps culture. And I don't think I have any time for questions, so no. All right, so thank you all for your time and attention.